In this class, we are going to talk about basic machine. In our previous class, we discussed that agricultural mechanization refers to the application of engineering principle. And I told you that this principle refers to the tools, you understand, the engineering knowledge. So the machines that we use with respect to our knowledge in engineering, the application of those machines in agriculture is what we call agricultural mechanization. Do you understand? So those machines are what we want to talk about now. Those are the machines that we want to discuss now. Do you understand? So let's start by defining what is meant by machine. Machine is a device that comprises of the stationary parts and moving parts. Are you paying attention? And both parts are combined together to generate, transform, and utilize the mechanical energy. Do you understand? That is the simplest definition of a machine. Machine is a device that comprises of a stationary part and a moving part, and with both parts are combined to generate, transform, and utilize the mechanical energy. Are you paying attention? Machine can be classified into machine generating mechanical energy. Okay, that is the first classification. Do you understand? Machine generating mechanical energy. Okay, and the second class is machine transforming mechanical energy. Please pay attention. The second class is the machine transforming mechanical energy, and the third class is machines utilizing mechanical energy. What do we mean by machine generating mechanical energy? The machine generating mechanical energy are also known as the prime movers. You understand? It combines some forms of energy such as heat, hydraulic, electrical energy into work or mechanical energy. You understand? Those are the machines that generate mechanical energy. Example of this machine includes gas and water turbines. Okay, the second classification is machine transforming mechanical energy. They are also called converting machines because they convert mechanical energy to other forms of energy. You understand? Do you understand it now? Machine generating and mechanical energy generate mechanical energy. Machine transform mechanical energy, convert mechanical energy to other forms of energy. Example of this machine include electric generator. Rotation of the shaft is converted to electrical energy. You can see now. So another classification of machines is machine utilizing mechanical energy. This machine receives mechanical energy and utilizes it for various purposes or for various applications. Example is lathe machine, which is used for cutting metal. You understand? Lathe machine is used for cutting metal. Okay, it's used mechanical energy to cut metal. Now that is about machines. Now let's talk about basic machine. Okay, basic machines are appliances or piece of equipment that uses power to do a particular job. Okay, basic machines are appliances or piece of equipment that uses power to do a particular job. Pay attention to the word appliances and piece of equipment. Okay, this power may be mechanical, manual, electric power. Example include mowers and threshers, which is used in the production and processing of crops. We are going to look at those ones as we delve deeper into this course. Okay, now there are 6 basic machines that we're going to talk about in this class. The first basic machine is lever. The second is the pulley system. The third is the wheel and axle. The fourth is the incline pin. The fifth is the screw and gears, and the sixth is the wedge. Before we delve into each of these basic machines, please pay attention. Before we delve into this basic machine, there are properties that are common to this basic machine that I listed. The first properties is mechanical advantage. Okay, properties. Please pay attention. Okay, mechanical advantage. Okay, advantage. The second property is the velocity ratio. Okay, and the third property is the efficiency. You understand? The third property is the efficiency. You see, all these properties are common to these properties are the common properties to the aforementioned basic machine. Okay, so there are some calculations under these properties. Let me explain the basic machine first before we delve into calculation. Okay, so let's start with the lever. That is the first basic machine. The lever, the first basic machine. Please, I want you to pay attention, okay? Because understanding this is crucial to your knowledge in this course, okay? So let's talk about the lever now. The lever refers to a simple machine that is used in amplifying force, okay? Lever refers to basic machine that is used in amplifying force. It has different types which include the first class lever, the second class lever, and the third class lever. That's not what we are concerned now. We are concerned about what it is used for. Now, if a questioner says, what is the function of a lever? Lever is used in amplifying force. Okay, this is how a lever looks like. We have the plane. You see, this is how a lever look like. You understand? Okay, now let's talk about the components of a lever. A lever has three components. You understand? The first component is the fulcrum. The fulcrum is also known as the pivot. This is the pivot. You understand? Pivot. Are you paying attention? Now, this is the load. You understand? I just described this as I use this diagram as the load. Load. And this is where the effort is applied. You understand? Those are the three components of a lever. You understand? Don't forget the function. The function of a lever is that it is used in amplifying force. You understand? Please pay attention. Okay? Now, on this lever we have two arms. Okay? On this lever we have two arms. We have the resistance arm and the effort arm. This is the resistance arm. Resistance arm. I'm going to explain, okay? And this is the effort arm. The effort arm. Now let me explain what is meant by resistance arm and the effort arm. You see, do you know that when you apply, let's say you want to, don't forget the function of the lever. The lever is used to amplify force. You understand? Now, if you apply effort, you apply force on the right hand side of this lever, this load will tend to move forward. Is that not it? Are you paying attention? Now, this is the effort arm. The arm where force is being applied in an attempt to lift up the load. That is the effort arm. You understand? Where effort is being applied, the arm is known as the effort arm. You know, this pivot divides this lever, okay, or the lever. This pivot divides this beam into two parts. We have the resistance arm and we have the effort arm. The effort arm is where the force is being applied before we can amplify the load, before we can lift up the load. You understand? That is what we call the effort arm. Now, because we call this arm the resistance arm, because that is where the load is. You understand? The load is at this arm. Hence, this load will tend to resist the force that is being applied at the effort arm. You understand? That is why we call it resistance arm. Do you understand? Okay, that is one of the basic machine. It is very, very important that you understand that. Now, let's proceed to the second basic machine, which is the pulley system. This is how the pulley system look like. We have the effort and we have the load that the effort applied is trying to lift. You understand? Okay? The pulley system refers to any lifting apparatus that makes it easier to lift an object rather than lifting the dead weight with the hand. You understand? You know, let's say you want to lift a block of 100 kilograms. You can easily lift the block using the pulley system. Are you paying attention? Any system that provides or aids in lifting an apparatus, or any system that provides or aids in lifting an object rather than lifting the dead weight of the object using your hands, that is what we refer to as pulley system. You understand? Now, in this pulley system, we have two types of pulley. You understand? We have the movable pulley and we have a fixed pulley. You understand? The pulley, okay, So that is what we call the pulley system. That is the importance. You understand? Now, in this pulley system, we have two types of pulley. The first pulley is the fixed pulley. The fixed pulley does not rotate. Are you paying attention? You understand what I'm saying? So this is the fixed pulley, and we have the movable pulley. Movable pulley and the fixed pulley. You understand? So you can see that this basic machine is also important on the farm. You understand? So that is for pulley system. Another basic machine that we're going to talk about is the wheel and axle. You understand? Okay, this is how a typical wheel and axle look like. You understand? On this wheel and axle, we have the load, which is here, the load, and we have the effort that is applied to lift the load. You understand? Okay, this is the wheel. You understand? That is why we call it wheel and axle, and this is the axle. On this wheel and axle, we have the wheel of the ratio, the radius of the wheel. You understand? The radius of the wheel is represented as big R. You understand? And the radius of the axle is represented as small r. Please pay attention, okay? This is the wheel and this is the axle. You understand? The diameter of the wheel is greater than the diameter of the axle. Hence, the radius of the wheel will also be greater than the radius of the axle. That is why I represent the radius of the wheel as big R. You understand? Wheel radius. Do you understand? And the radius of the axle as small r. That is the axle radius. This is S, okay? Radius. Axle radius. Do you understand? Just pay attention to those concepts that I'm explaining. You understand? By the time we delve into work example, it is going to become clear. Are you paying attention? So this is a typical diagram of wheel and axle. Okay, another basic machine that we're going to talk about after the wheel and axle is the inclined plane. Okay, the inclined plane. Okay, this is how the inclined plane look like. It looks like a right angle triangle. You understand? Where we have this is the smooth surface here. You understand? And we have an angle here. We have an angle here also, and we have an angle here. You understand? This is the shape of the inclined plane. Okay, let's take down some explanation on the inclined plane. The inclined plane is a simple machine consisting of a sloping surface. You understand? This surface that you see here is sloped downward. You understand? This is the sloping surface. This is a basic machine consisting of a sloping surface. You understand? This surface is sloped downward. It is used for raising heavy bodies. You understand? Example include the ramps, the stairs, the slides, and the escalators. You know, if you have ever tried climbing the stairs before, you will see that the stairs slope downward. It just look like an inclined plane. You understand? So that is how inclined plane look like. There is one thing that I want you to pay attention here. There is some when I start this class, I gave you 3 properties that is common to this basic machine. These are the mechanical advantage, the velocity ratio, and the efficiency. Now let's quickly discuss the mechanical advantage and the velocity ratio of inclined plane. The velocity ratio, the VR of inclined plane, is equals to 1 over sine theta. You understand? That is the formula for calculating the velocity ratio of inclined plane. Now, how do we determine the mechanical advantage? Now, there is a condition. If the velocity, okay, if friction is neglected, you understand, that is, there is no friction along this sloping surface, then the velocity ratio is also the same thing as the mechanical advantage. Do you understand? I will take that again. If friction is neglected, that is, this surface is frictionless, the mechanical advantage is the same as velocity ratio. Hence, the mechanical advantage of inclined plane is also the same thing as what? 1 over sine theta. Do you understand? Okay, as we delve more into this course, I'm going to explain what other things that you need to know about the inclined plane. Do you understand? Then, the 5th basic machine that we're going to talk about is the wedge. You understand? Okay, this is a typical representation of the wedge. The wedge is a very simple machine that is triangular in shape. It is normally driven into an object to force them apart. You understand? And based on this shape, we can call it the combination of two inclined planes. Based on the shape, look at this. This is an inclined plane. This is an inclined plane. An inclined plane is a right angle triangle. And let's say we have another inclined plane. If you combine both inclined plane, it will become like this. You understand? We are going to have something like this. Based on the shape, it is a combination of two inclined planes. Do you understand? That is the wedge. The wedge is forced into an object to drive them apart. For example, let's say I have a block of wood here. Let's say we have a block of wood, and I want to cut this wood into two. I can use wedge. You understand? Depending on the shape of the wood, I can use the wedge. I will just have to apply hammer. You understand? I just have to apply hammer at the head. Then this block will split into two. You understand? That is one of the importance of the wedge. Are you paying attention? So the wedge is a simple machine that is used to that is driven into an object to force them apart. Are you paying attention? So the sixth basic machine that we're going to talk about is the screws and gears. Screws and gears. Okay, let's first talk about the screws. You understand? Please, I want you to pay attention. Okay, now the screws is a basic machine that converts rotational motion to linear motion. You understand? Example is the screw jack. Okay, let me have a structure here. Let us have a structure here. We have, let's say this is a screw jack. You understand? Don't forget the function. The function is that we have the load. This is the load, and this is the this place is the effort. You understand? Even I can let me do another screw. Let us have another screw here. Now, don't forget the function. We define screws as basic machine that convert rotational motion to linear motion. I will explain. Do you know that? Let's say you have a screwdriver. If you have a screwdriver, you can try this. If you have a screwdriver, try screwing this screw on an object. You will realize that immediately you are as the screw completes one rotational motion, one oscillation, this screw will be driven forward. Let's say we have a block of wood here. You understand? Now, as this screw is being rotated at the head, you understand? Because you apply the screwdriver, as you begin to screw it, this screw will begin to be driven into this wood. You understand? So in this case, as this head is rotating, this screw begins to travel downward. You understand? That is, as this screw make a complete revolution, it begins to travel forward. You understand? That is it. Screw is a basic machine that converts rotational motion to linear motion. You understand? So when you apply screwdriver to rotate the head of this screw, it will travel forward. You understand? Even into the wood. You understand? That is why we call it a basic machine that transform a rotational motion to linear motion. You understand? Example of screws is the screw jack. You understand? Example of screw is the screw jack. We can see where the load is and we can see where the effort is. But in the screw jack, there is something called the pitch. There is something called the thread. Okay, there is something called the load, the thread, and the pitch. You understand? Let's say, okay, let me redraw this for the sake of clarity. You understand? Okay, this is the thread. You understand? The distance, please pay attention. Okay, please pay attention. The thread is where I just rule out. You understand? Now the pitch is the distance between this place and this place. This is the pitch. The distance, pitch. The distance between this place and this place. You understand? Don't worry. As we delve into this course, I'm going to explain. By the time we start the calculation under each basic machine, you are going to understand better. You understand? Okay. So now let's move to gears. Okay. So let's talk about the gears. Okay. Do you understand? Now, the gears are mechanisms that mesh together via teeth and are used to transmit rotational motion or
rotatory motion from one shaft to another. Take note of that. They are mechanisms that mesh together via teeth and are used to transmit rotational motion or rotatory motion from one shaft to another. Okay, now let me quickly draw the structure of the gears. You understand? This is how a gear look like. I hope I got this right. Please just pay attention, okay? Yeah. This is a typical example of a gear. You understand? So you see, these are the teeth of the gears. This is the teeth. Do you understand? Now, please, I want you to pay attention. I want to show you how we use this gear. Are you paying attention? So, gear can be used to increase speed or decrease speed. You understand? Gears can be used to increase the speed, or decrease speed. Now, let's say we have two gears. Let me have another gears here. Let this one be smaller. You understand? Let this one be a smaller one compared to the previous one that I drew. Now, okay, this is the bigger gears, this is the smaller gears. To increase the speed, I pay attention. For we to use gears to increase speed, we have to mesh two gears together. You understand? Don't forget the definition of gears. They are mechanisms that mesh together. So now let us mesh this gear and this gear together. Okay, so we are going to have something like this. Please, I just want you to pay attention. Okay, we're going to have something like this. If we mesh both gears together now, we're going to have something like this. And for this, let me just have something like this. For the third one, for the small one, guys. Now, when I combine these gears and these gears together, this is what we call mesh. You understand? Are you paying attention? Now, when this gear mesh together, are you paying attention? They convert rotational motion. Now, let's say this gear is rotating in this direction. Are you paying attention? Please, just pay attention. You're going to understand. Let's say this gear, the first gear here, is rotating in this direction. That means that this gear will be rotating in this direction, because this shaft, the teeth here will mesh with this teeth, and in that case, this gear, which is the driver, let me call this one the driver gear, and this is the driven gear. You understand? The driven gear. Please just pay attention to the explanation, okay? You're going to understand. Now, this is the driver gear and this is the driven gear. Now, let's say this gear is rotating in this direction. Now, because the teeth of this gear has been meshed with the teeth of this gear, it will cause this one also to oscillate. You understand? Now, which direction will this other gear will be oscillating? It will be oscillating in this direction. You understand? Because when these teeth mesh with this teeth will force this teeth to move this teeth will force the teeth of this gear to move clockwise. You understand? In that case, this gear, the driven gear, will be oscillating in clockwise direction. Do you understand? If you don't understand, listen to the explanation again. Okay? So now, how do we use gear to increase speed and how do we use gear to decrease speed? That's what I want to explain now. Okay? How do we use gear to increase and decrease speed? To use gear to increase speed, are you paying attention? Please, I want you to pay attention now. To use gear to increase speed, the driver gear must be bigger than the driven gear. You understand? Okay? Let me give an illustration here. You can see that. Okay, let me do another gear. Let's have another gear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, this is one gear. Let's have another gear here. Another gear.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want the teeth to be 10. You understand? I want the teeth. Please pay attention. I want the teeth of this gear. I want the teeth of the second gear to be 10. You understand? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You understand? Okay, now the teeth of this bigger gear is what? Is 20. The teeth of this second gear, which is the smaller gear, is what? 10. Now, this is the driven gear. Let's call this gear A and let us call this gear B. You understand? This is the driven gear. Okay, this is the driver gear rather. Okay, let's call the bigger gear the driver gear. Okay, this is the driver gear and this is the driven gear. I'm going to explain. Please just pay attention. Okay, now the gear that is being driven by the other gear is what we call the driven gear. You understand? The gear that is moving as a result of the movement of the other gear, that is what we call the driven gear. Hence, this smaller gear is the driven gear. You understand? Now, in this case, we are increasing the speed. The reason is because the driver gear is bigger than the driven gear. You understand? And the teeth of the driver gear, before the driven gear can make one complete revolution, if you have to travel twice. You understand? But this bigger gear has 20 teeth. Okay, let me quickly explain that. We have how many teeth in this gear? Okay, let's talk about this. How many teeth do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This 12 teeth. A gear with 12 teeth. And we have 20 teeth here. We have 10 teeth here. Now, the ratio of their teeth is now what? 2:1. You understand? Please pay attention. The ratio of their teeth is 2:1. 2:1. And the reason is because this gear has 20 teeth. And this gear has what? 10 teeth. That is, I'm going to have 20/10. That is what? 2/1, which is what? 2:1. That is the ratio of the driver gear to the driven gear. Now, I'm not focusing on that. What I want to explain to you is that to increase the speed, if the aim is to increase speed, the driver gear, that is the gear that causes the other gear to move, must be bigger than the driven gear. You understand? So that is it. Now, to decrease speed, that will be vice versa. To decrease speed, the driver gear must be smaller than the driven gear. You understand? Pay attention. You know that this one is to increase speed. For here, we are increasing the speed. You understand? Now, if the aim is to decrease speed, you understand? If the aim is to decrease speed, the driver gear must be smaller. Okay? The driver gear must be smaller than the driven gear. You understand? Oh, this one is too far. You understand? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, that means I'm going to have 9. You understand? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's supposed to be 9. You understand? It's supposed to be 9. I want to make it 9. 9. Okay? Now, this is the driver gear now. Okay? This is the driver gear, and this is the driven gear. Now, the meshing together of this gear is to decrease speed, and the reason is because the driver gear is smaller than the driven gear. You understand? So that is the explanation. Okay, that is the explanation. For we to increase speed, the driver gear must be bigger than the driven gear. To decrease speed, the driver gear must be smaller than the driven gear. You understand? Okay. So, having understand what is meant by basic machine and the types of basic machine that we have in agricultural mechanization, we are going to stop here for this class. You understand? All these basic machines have formulas. They have, we start from explaining the properties that is associated with, that is common to this basic machine. This include the mechanical advantage, the velocity ratio, and the efficiency. Each basic machine has its own formula. You understand? So
we're going to focus and we're going to delve more into it in our next class. You understand? Please don't mind my drawing. You understand? Don't mind this drawing. Just pay attention to the explanation. Okay? So see you in the next class.
To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay? See you in the next class.